Hey everyone, my name is Isai. I will be doing the video today. My partners Chase, David, and I, we did the statics problem. That's what I'm going to be talking to you guys about today. Unfortunately, my computer doesn't allow me to pull up the actual problem, so I'm just going to be giving you a summary of what the question asks us to do. So for the static problem, we are given a total of 4 tasks. In the first task, it asks us to set up the problem. So for task 1, we are given a free body diagram. For task 2, it tells us to check our input data. This is where we are given our inputs D, W, and LAB. For task 3, we are asked to create a function. This function should solve and output the angle theta and both of the tensions. Last is task 4. Here we are asked to determine the max of LAC. So I'm going to be showing you guys how we solved each of these questions using MATLAB. So we start off here with the data, where we have statics, D, W, and LAB. Now for D, we have to make sure that the length of D is positive. And also in task 2, it tells us that D should always be greater than LAB. Now for our next input W here, we also have to validate that the weight is positive, and we also have to convert it to newtons. So we do that by multiplying it by whatever you input times 9.81. For LAB, we have to also validate that the length is positive, and we also have to make sure that LAB is less than D, because that is what task 2 tells us to do. So for statics here, we use XLS read. XLS read allows us to use Excel. So we name the file, the Excel file A, and then all we do is type in the name of the file here, and then it allows us to use Excel to type in our inputs. So for our first column here, A1, so A1 here represents D. B1 here represents W. And C1 here represents LAB. So right now I inputted the number -1 for D, the number 9 for W, and the number -5 for LAB. If we were to run these numbers here, the -1 and the -5 for D and LAB will turn positive because of the absolute value used in the code. So this is because in task 2, it tells us that each of these has to be positive. So if we were to run this section right now, this would pop up in the command window. This here, enter value of D that's greater than LAB, enter new value of D, pops up in the command window because of this while loop here. So what this while loop does is that if LAB is greater than D, or if D is less than 0, then it will ask you to enter a value of D that's greater than LAB, like it tells us to do in task 2. If the user were to input a negative value after this pops up in the command window, then this warning here will pop up and it'll say you have a negative D value. Input again. And this will keep going until the user inputs a positive value and makes sure that the input for D is greater than LAB. So this takes us to our next 2 inputs in the function that I'll be getting to in a moment, LAC max and LAC min. So in order to calculate the max, we take the square root of the larger value, D squared, plus the smaller value, LAB squared. and that's to get the max. To get the min of LAC, you take the larger value D and subtract it by the smaller value LAB. We then call on our function static fun. So this takes us to task 3, which tells us to create a function in which it has the outputs TAB, TAC, and X, and has the following inputs WD, LAB, LAC max, LAC min. And then it tells us to name this function static fun. So in this function we use a for loop where we have LAC equals, and we start off at the LAC min, and then it takes steps of 0.2 all the way up to LAC max. Here we use theta lab. We use this equation to tell us where the angle of LAB is at. And then theta LAC to tell us where the angle of LAC is at. So then T1 here gives us the tension for LAC, and then T2 here gives us the tension for LAB, which then takes us here to our outputs. Here we have TAB, which is the array for tension of lab, and then TAC, which is the array for tension of LAC, and then X here, which is the X-coordinate correlation for tensions. So going back to our script here, then we take our initial values and replace them with 0. We then use the max function here in order to find the max values for tension in LAC and LAB in newtons. Then this here takes us to our graphing, where we have our title, our X label, Y label, and we have the grid on, and then we set our X bounds for the graph. In order to find our Y max bounds here for the graph, we use conditionals where if the max of TAC is greater than TAB, then our Y max bound is TAC plus 10. If not, if it's the other way around, if TAB is greater than TAC, then our Y max bound is TAB plus 10 instead. So in the graph, our Y is going to start off at 0. That's going to be our min. And here's the axis, which sets the limits of the X and Y. So then we head over to plotting the points. Here we plot our outputs for static fun, and we gave each a different color. And not just different colors, but different shapes are included as well for TAC and TAB. So once we graph, this will definitely help each stand out on its own. Then it takes us to our legend, and then our F-printf statements here. So this first F-printf statement will give you the max length of LAC, which is actually what task 4 asks us to do. And like I said before, task 4 is the last task we are given. The second F-printf statement will give us the max tension of TAC. And then the third will give us the max tension of TAB. And that is the last of our script. Sorry guys, because of the app that I'm currently using, it only lets me record up to 10 minutes. So if you guys scroll down, I will be providing a link to the next video, which is a continuation of this video, and it won't be too long. It'll only be like 4 minutes long. So yeah, I'll see you in the next video.